Those memory addresses that we've been using are about to become really useful. It turns out that you can modify the contents of some objects, and without memory addresses, it would be really hard to explain what is happening. We'll start by showing that list objects can be modified. On line 1 is an assignment statement. We evaluate the expression on the right-hand side, and that creates a list object, as well as the 6 integers 0, 2, 4, 6, 8, and 10. Once we have created that list structure, we're going to assign to variable lst the memory address of the list object. So list, lst, contains memory address ID 1, which refers to the list object. At index 0 is memory address ID 2, and that refers to the 0 object. At index 1, we refer to the 2. At index 2, we refer to the 4, and so on. On line 2 is another assignment statement. On the left-hand side, we don't just have a variable. We have something a little more complex. We have list at index 2. We're actually going to be modifying that memory location right there. List at index 2, after we execute that assignment statement, is no longer going to refer to the integer 4. Instead, it's going to refer to integer 5. We are going to be modifying an object in the heap. When I click forward, we see that we have a new object at memory address ID 8, and that list at index 2 refers to that new object. Let's go edit the code and do something else. I'm going to replace this code with some other code. Let's visualize the execution. Line 1, we know what to expect. List 1 refers to a list. That list at index 0 refers to 0. List at index 1 refers to 2. List at index 2 refers to 4, and so on. On line 2, I'm doing something rather curious. I am taking the memory address that's in variable list 1, and I am placing it in variable list 2. The only thing that's going to change is the contents of module main. There we go. Now, both list 1 and list 2 refer to the list object. This is called aliasing, when two variables both contain the same memory address. Aliasing happens. So far, so good. What we're going to do now is we're going to assign to the last item in list 1, or the object that list 1 refers to, the value 17. So the item at index 5 is going to change in the list. We're going to lose the reference to 10, and instead we're going to have the item in index 5 refer to the integer 17. And there we have it. The interesting thing now is that list 2 got to watch that change happen. List 2 contains the memory address of the list object. We changed that object by using list 1, but list 2 changed as well. So when we print list 1 at index -1, print the last item, we get a 17. And we're going to see exactly the same result when we print list 2 at index -1.